All right, I'm back and gonna try to finish these notes. So again, if you already know what you're doing, you may already have finished these problems. If you just want to watch, maybe you just miss seeing me. Who knows? But I'm gonna go ahead and do these and hopefully get them right. So I'm gonna number these 1 and 2, 1 and then 2. All right. So for curve number 1, I think that looks like a negative sign limison without an inner loop. So what I'm going to do is I'm going to find the values and go from there. So, and I'm going to skip the table this time, and I'm just going to make the rectangular graph. Let's see how that goes. So that's a good start. All right, so my first distance that I'm going to measure is from here to here. So I think that is 4, 5. So I think 0, we're at 5. And then what's going to happen? So it's going to like decrease. So 5. And I'm there at 0. And then the next distance that I'm going to find is this distance, which is 2. So we're going to go to 2. And we'll be there. And then, whoa, when I get to, I'm actually like moving this all over the place on the iPad. It just doesn't move when you see it on screen, which is kind of like an amazing feature. So we're going to go to the left here now. So this distance will also be 2, 4, 5. And so already I like know what this is going to be, right? It's going to be 5 minus 3 sine of theta. But you can keep going. And so I knew that it was that because it's starting in the middle, goes to a minimum, and then the distance is 3 between them. But if you wanted to, so usually when I do that extra step, I screw it up. So let's see if that happens. 4, and then -4, so that's 8. So I'm not going to mess this one up. Okay, so we'll be at 8, which makes sense. We'll be there, we'll be there. You can draw a curve. Use another random color like this. And so I know that this will be r equals 5 minus 3 and sine of theta. So pretty much what I was expecting, right? I was expecting a limison, a negative sign limison, and I wanted the coefficient to be less than the constant because that won't give you an inner loop. So good deal. And then the center is shifted to, man, -4, 4, just using that all the time. So my shift is -4, 4. And then once we have all of that, we can write the equation. So I'll write it and then move on to the next problem. X is -4, y is 4, and then plus. So going through this process, I'm noticing that I repeat a lot of things in the notes. It'd probably be better if I had more variety, I guess, of examples. So maybe, who knows, maybe this summer, maybe I'll send myself an email and I can sit with the other 1,000 emails of things I should change. And maybe I'll get to it at some point. Super hard to say, who knows? All right, number 2, if I wasn't given the center, like the origin, the shifted origin, I might have thought this was a circle, but you can definitely see that if we put our axes in, it definitely is not a circle, right? It's 3, you go 3 to the right, or whatever we're counting by, 6 to the right, and you only go 4 to the left of the center. So it is not that. So it's actually a positive cosine limison. So let's see if we can work out what it is though. So this distance from here to here is 6. And then this distance from here to here is 2, 4, 5. And then this distance from here to here is 4. So positive cosine is going to start out here and then go this way. So I can make my rectangular graph. if I feel I need to, which I feel like I'm compelled to because I'm making the video. On my own, would I make it? I mean, probably, just to be on the safe side. Like, it doesn't hurt anybody. So it's going to be here, here. So I'm getting that positive cosine that I was expecting. It's kind of a weird one. Okay, looks like that. So I'm going to say R is 5 plus 1 cosine of theta. And then I know that my shifted origin is here, which is 6, negative 6. So let's write some equations. So x equals y equals, all right, so 6, negative 6, 6 here, negative 6 here, and then, okay, so plus the quantity, 5 plus cosine theta, and then plus 5 plus cosine. I don't know if I mentioned this. I don't know if you can hear it, but my neighbor decided to start chainsawing today. He chainsaws a lot. I mean, he definitely heats his house using wood. And so I guess you just need a ton. Sometimes he just gets like a dump truck of wood delivered. Then he goes out and uses his chainsaw, cuts it up, just like got cords and cords of wood just sitting around waiting to be burned at some point. But there's a lot of chainsawing. And now that I'm home, I get to hear it. All right, so I think those are our equations. Let's take a look at potentially the next one. All right, what are we dealing with here? So we got two curves, two limicons. So 1 and then 2. 2 looks like it might be a little tricky. So let's see what we can do. So for number 1, though, I feel like we can breeze through this potentially. So this distance is going to be 4, and that's when theta equals 0. And then when theta equals pi over 2, we're going to get like this distance, and that distance is 4 and then 5, so 9. And then so this other distance that I could find is here, and it's 3. So 4, 9. Oh no, it's going to be negative 3 though, right? The distance is 3, but it's negative. That had me tripped up there for a second because that's at 3 pi over 2, but it's going toward the positive y-axis. So it's actually negative 3. So maybe I'll put a negative sign there. So I was looking at it and I was like, well, this is definitely wrong. But now I'm at 4 and I can go, oh wait, all of this is wrong. Oh, not all of it's wrong. Oh man, this is it. This is why I missed my class. That wasn't 4. I didn't go far enough. It didn't make any sense. So in my head, the thing that was causing me pain in my head about this was that I couldn't tell. Oh no, wait, it was 4. Oh, jeez. What am I doing wrong? 4 is, oh, it's not 4. It's 3. This is 3. All right, I mean, like, I'm going to leave this in because I feel like I probably didn't curse. And I think it's good for you to see that, like, sometimes people screw up, especially when they're trying to go really fast. All right, so let me make a rectangular graph of that information. So I'm going to go negative 3, 3, 9. So the way that I could kind of tell that something was wrong was that the distance from 4, when I thought it was 4, from 4 to 9 is 5, but then from 4 to negative 3 is not that. So I knew something was wrong. And so I had to like figure out what it was, and you heard the whole thing. You were there. It was a disaster, but it was okay. All right, so when theta is 0, I'm at 3. When theta is pi over 2, I'm at 9. So I already know what I'm dealing with, but let's keep going. So we get this. I'm not trying to do sloppy work. I'm just doing work, as if I were doing homework or something like that, where, you want to make sure you know what you're doing. Why would you write cosine there? you know, you want to make sure you know what you're doing, but you don't want to spend all day on it. So we get this, and then my shift. Remember, the shift for these is where the inner loop starts and stops. So that's going to be right here, which is at -4, -4. Ooh, mixing it up. Not really, though. Still all 4s. And so we can write our equations. X is, Y is -4, -4. Plus, I feel like at this point you maybe don't need me to write this, but I mean, I feel like I might as well. Sine of theta, and then cosine theta. So I mean, like, my face is in the video, but mostly you're just seeing me look down, which, you know, maybe someday I'll figure out a better way to do that, but it's not going to be today. Okay, so that's that. The next one looks pretty challenging if you don't know how these limicons work. So I know that this should be a negative cosine limicon, right? Because it's if that point that we're given is the origin, then everything is to the left of it. And the inner loop, it turns out, is just enormous. But remember, you start at a negative. So theta is 0, you're facing to the right, but you're going backwards. So this distance is going to be, what is this? 2, 4, 6, 8. So -8. And then I kind of have no, so that's at 0. I don't really know where I am at pi over 2 at all. But I do know that at pi, I am this far. That was not a straight line. So that far is going to be 10. So I know there's some middle number, right? But what I definitely know is that -8 and 10 are involved. So let's do this. So we got -8 and then 10. And then what's in between those? So 1. Okay, when theta equals 0, I'm at -8. So I'm going to do tick marks for this. This will be at 2 pi. Okay, so I'm also there at 2 pi. And then when theta is equal to pi, I know that I'm at 10. So then I must be here in between. And so even though it's challenging, we can still work it out. So this is going to be 1 minus 9 cosine of theta. 1 minus 9 cosine theta. So it seemed like it was going to be really hard, but turns out you don't need all of the values. You just need to know where you are at specific values. And we definitely know enough to know that. So I get this, and then the shift is at, what is that, 10, -6? So let's write our equations. This gross orange color. And maybe we can fit them here. So x is, y is, and what did we say, 10, -6 plus 1 minus 9 cosine theta, and then cosine theta, and plus 1 minus 9 cosine theta. So, I mean, if you've been with me this whole time, good for you. I hope these are working out for you. Trying my best. I feel like this is a good thing. Let's keep going. We're like almost there, potentially. All right. So just going to write the equations. These I think we can do. This one, so curve number 2 is a circle, I think, because I can't think what else it would be. So I'm going to do it as if it's a circle. And curve number 1, I think I can do without really doing any work. So let's see. First, the shift. So -4, 4, obviously, because that is the shift on every problem that we do. -4, 4, and plus, let's see, plus. All right, so it's going to be cosine because there's a pedal on the x-axis. There are 8 pedals, so n is equal to 4, and the radius is 4. I feel like we've done this problem like 10 times. All right, so 4 cosine 4 theta cosine theta, and then 4 cosine 4 theta and sine theta. I mean, like, that one you definitely know by now, right? I hope. Let me move it just in case my face is in the way. It's like the one thing I'm having trouble getting used to is that there might be a picture of me obscuring part of this. All right, so this one, I'm thinking that, so we got a circle on the positive x-axis. What is the radius of this? The diameter is 5 rather, and that's actually what I need. So I'm going to do this in one shot too. Okay, x equals y equals. So the shifted origin is 5, -3. 5, -3, plus, plus. It's a circle. The diameter is 5, positive x-axis, so it's going to be 5 cosine theta, and then cosine theta, and then 5 cosine theta, and sine theta. Okay, I think that's it for those. Let's see what the next, and I think possibly the last pair of graphs will be. All right, so 2 annoying overlapping limicons, both of which have inner loops. Great way to close it out. All right, let's see. So let's label them 1 and 2. And I think we got this. All right, so first of all, I'm going to say that this distance is definitely 2. And then, so we start there, then we go to here. This distance, directed distance, I guess, is going to be -2. And then by the time we get here for 3 pi over 2, the distance is 2, 4, 6. I do a surprising amount of counting rather than like subtraction. So I'm going to plot that just to get a sense of it. Although I feel like we could work it out, but let's plot it anyway. So here, this will be -2, and then 2, and then 6. All right, so at 0, we're here. And then by the time I get to pi over 2, I'm down at -2, and back here, here, here. So I can see that it's 2 minus 4 sine theta. 2 minus 4 sine theta, which if you've done enough of these, you were expecting a negative sign thing because it's predominantly on the negative y-axis. And then our shifted origin, of course, is -4, 4. So our shift is going to be -4, 4. So let's write this equation. X equals y equals -4, 4 plus our r, which is 2 minus 4 sine theta, and then plus 2 minus 4 sine theta. And you never want to forget that cosine and sine. So cosine, that's what like takes it. It makes it the parametric thing you're looking for. Sine theta. Whew. All right, one more. Let's knock this out. All right, negative cosine limicon with an inner loop. They always start in the middle, and they start with a negative r value, which is kind of the weird part about them. So this looks like that's going to be -2. And then what I'm going to do is dot in that so that I can see that this distance is 4, which is actually like kind of enough information. But if you're not sure about that 4, which I can imagine being a little suspicious of, you can do this distance, which is going from 5 to -5. So this is 10 when theta equals pi. So let's sketch a rectangular graph. So what do we need to, we need like a lot. Okay, so -2, 4, 10. It's really comforting when you make the y-axis for this, or it's really the r-axis for this, to see that the things that you're putting on it differ by the same amount, that means you're like almost certainly right. Because that has to happen with the trig function, right? The amplitude is the amplitude. And so let's see what we get. 1, 0, we're here, then here, then here, here, here. So negative cosine, which I was expecting. And it has an inner loop, so this looks like it's going to be good. So R is 4 minus 6 cosine of theta. All right. The center in this case was shifted to 5, -3. So that's the craziest shift we've seen. Took a long time, but we got there. 5, -3. Not a single 4 involved. How weird. All right, and let's write these equations and then call it a day on these notes. So there's one more page in the notes that is entirely review problems. I think there's only one more page. There might be 2 pages. It's all review problems. You should definitely take a look at those, see if you can do them. Those are great things to ask questions about when we try to meet online, which hopefully we'll be doing. All right, 5, -3 plus 4 minus 6 cosine theta, and then cosine theta, and then plus 4 minus 6 cosine theta sine theta. All right, and I think that is it. So I'm going to stop this here. I think we made it through these notes, and that's an awesome accomplishment. So good job, everybody who is still with me.